everybody. You can give Wes a thanks for that one. I thought that was a cool video. That was a beautiful shot by VJ. He skimmed it off the water and then popped in for a hole-in-one. That was at the Augusta National, I believe. So thanks again, Wes. All right, I have the last 3 word problems here that you guys can take a look at. So let's get to it. A scientist studying bacteria growth in yogurt cultures notices that after beginning with 150 bacteria in a particular sample, the number of bacteria grows at a rate of 13% each hour. After how many hours will the scientist's yogurt sample have more than 1,200 bacteria? Round your answer to the nearest tenth of an hour. Okay, so take a look here. Okay, we have our growth model. Exponential growth is A equals your principal, 1 plus R raised to the T. Okay, it's a plus for growth, it's a minus for decay. Keep that in mind. So my principal, or what I'm starting with, is 150 bacteria. The interest rate is 13%, or 0.13. And what I want to get to is 1,200. Okay? So, I'm going to go ahead and solve for this. I'm going to go ahead and divide both sides by 150. I got 1,200 divided by 150. Oops. Gives me 8. So 8 equals, I'm going to go ahead and add these two together. I get 1.13 T. Now, I have to get the T out front. The only way to do that is to take the log or the natural log of both sides. In this case, the thing raised to the T value is 1.13, so it's neither an E or a 10, so it doesn't matter which one I pick. Let's go with natural log. So then over here I can write natural log of 8 equals T natural log of 1.13. How am I doing that? Well, I can take my exponent and pull it out front. Divide both sides by 1.13. So T equals natural log of 8 divided by natural log of 1.13. How does that look in the calculator? So natural log of 8 divided by natural log 1.13. I get 17.01. Okay, it says around there is 10th. Well, basically you want more than 1,200, so 17, what is that? 17 hours? Okay, you're all good. 17 hours, you're going to get around 1,200 and then go over it. Okay? Cool. So, number 2. Emily deposited $1,500 in 2 separate high-yield savings accounts that are both earned 3.05 interest. The interest on her $15,000 deposit in Bank A is compounded continuously. Guys, we have A equals P e to the RT. This is our PERT formula for continuous. And then we have A equals P 1 plus R over N raised to the NT power. Okay, where N is the number of times it's compounded. So the first one, Bank A, is compounded continuously. I'm going to use this one. So my principal is 15,000. E raised to the interest rate is 0.0305. And the T, it says, after 12 years, she decides to withdraw the money from both accounts. All I'm doing is plugging stuff in. So I got 15,000 for the first one times E, second division sign, raised to the 0.0305 times 12. So I am earning $21,629.33. Not a bad little chunk of change. Let's see, the other one was Bank B is compounded quarterly. So the only thing different over here is my principal is 15,000. 1 plus, my interest rate stays the same. The N is 4. Okay. Pardon me. Times 1 plus. I like to put extra parentheses here. Divided by 4. Close it. Raise it to the 4 times 12 power. And I get $21,599.32. Okay, guys, please make sure you're reading directions. It then says, how much money does Emily withdraw from her savings account in Bank A? How much more money does she withdraw from Bank A than Bank B, assuming she empties both accounts? All I'm going to do is take this one, 21,629.33, and subtract 21,599.32. Guys, I cannot tell you this enough. As long as you're listening to this video, make sure you read the directions on the test. You'll see what I mean when you get to the test. If I subtract these, $30.01. So that's how much more money she made by compounding continuously over quarterly. Okay? Awesome. Number 3. A simple technique that biologists use to estimate the age of an African elephant is to measure the length of the elephant's footprint and then calculate its age using the equation L equals 45 minus 25.7 E raised to negative 0.09 A, where L is the length of the footprint in centimeters, and A is the age of the elephant in years. Calculate the age to the nearest tenth by an elephant whose footprint measures 32 centimeters. I'm plugging this in for L. Okay, I can subtract 45 from both sides. Negative 13 equals negative 25.7 e to negative 0.09 a. I have to divide both sides. Let me just double check this real quick because I've been known to make mistakes in the past. All right, good. I can divide both sides by negative 25.7, and I get 13 divided by 25.7. I'm going to leave that there for a second. Now, look at the base. Is it a 10 or an e? Yes, it's an e. I'm going to take the natural log of both sides. So, natural log of 13 divided by 25.7 equals, I can pull my exponent out front, negative 0.09 a natural log of e. What happens to natural log of e? It goes away. So to get a, I'm just going to take natural log 13 divided by 25.7 and divide it by negative 0.09. Okay, so let's take a look at what that looks like. Divided by negative 0.09. I get my A is 7.57. It tells me around the nearest tenth, so 7.6 years. Okay? These are basically your 3-word problems for Thursday for this test coming up. Okay? So keep that in mind. Alright, on the back, complete the following problems without the use of a calculator. This will be a small portion the next day for without a graphing calculator. Okay? It's just basic properties. The one thing I recommend for all of these is set them all equal to x. Let's rewrite it. The base of natural log is e. E raised to the x power equals e to the 7th. What does x have to be? Just 7. Okay? It's just a basic property. It's just rewriting all of them. If you can rewrite all of them, you're going to get at least partial credit. 9 to the x equals 1. What does 9 have to be raised to in order to equal 1? It's just 0. Here. 1/6 raised to the x power equals 216. In order to get 6 from the denominator to numerator, my exponent has to be negative. And then 6 raised to what power gives you 216? 3. Okay. What's the base of this over here? It's common log, so it's 10. 10 to the x equals 1 over 100. How do you flip it? Guys, if you need to flip it, it has to be negative. And then 10 raised to what power gives you 100? 2. Finally, down here, okay, complete the following statement. Log base 5, 53 lies between the consecutive whole numbers what and what. Think about this. It's 5 raised to the x power equals 53. So you're trying to think, what whole numbers? So 5 raised to what power and 5 raised to what power will be its boundaries between 53. So think about it. 5 to the first is 5. 5 to the second is 25. 5 to the third is 125. 5 to the fourth is, I think it's 625. What does 53 fall between? 5, 25, 125, 625. Right about here. So what whole numbers are they? 2 and 3. Done. Okay? Expect something very, very similar to that. This is everything. Okay? This is all you need in order to do well on this test. So as always, keep up the good work and good luck. We're all counting on it.